So just to preview what Unit 3 is about. Systems of linear equations and inequalities. So we're going to look at what they are. And then we're going to focus mostly on solving equations. Doing it by graphing, by substitution, by elimination, and solving systems with 3 variables. So that's pretty much what we're going to be going through over the next 3+ days. Again, if you have questions, you have to ask because I can't read your mind. That means if you don't ask questions, I get to assume that you know what you're doing. All right, so let's begin. So a system of linear equations or inequalities is a set of 2 or more equations and inequalities that you're going to solve simultaneously. So it's 2 or more equations or inequalities, you're solving at the same time. So a solution would mean it satisfies every equation that you have, or every inequality that you have. So for example, first example here, so this is a system of equations. 3x plus 4y equals 19. 2x minus 5y equals negative 18. So if I give you a solution, that means it has to work for both equations. It has to work for both of them. So how do we know that it works? If they give us the answer already, we plug it in and see if it works. So 1 comma 4 means x equals 1, y equals 4. So we plug them in. 3 times 1 plus 4 times 4 equals 19. So 3 times 1 is 3. 4 times 4 is 16. 19 equals 19. It works. Now we check the other one. You must check both of them. It has to work for both parts of the problem. 2 times 1 is 2. 5 times 4 is 20. Negative 18 equals negative 18. Checks out. So it works. Checks out. So it works. So the first one works, but the second one doesn't, then the answer fails. The answer is a fail. It has to work for both. Let's do example 2. So this time we have a set of inequalities. That's okay if they're inequalities. Same rules apply. You take the answer, take their answer, plug it in. So I'm telling you that it doesn't work. So I'll show you why it doesn't work. 4 times 2 minus 3 times negative 3 greater than 10. What's 4 times 2? Called a layup problem. I was about to say, that's called a layup. 8. Negative 3 times negative 3 is 9. 8 plus 9 is 17. 17 greater than 10, that's true. So that checks out. But now we got to check the other problem. X plus 5y is greater than or equal to negative 3. So 2 plus 5 times negative 3 is greater than or equal to negative 3. So 2, what's 5 times negative 3? Nice. 2 minus 15 is negative 13. So we have to check to see if that is true. So negative 13 greater than negative 3? No. Negative 3 is the bigger number. Is negative 13 equal to negative 3? No. Those numbers aren't equal. So this is false. So that's why that answer doesn't work. In order for an answer to work, it's got to work for everything. It's an all or nothing deal. It works for everything or it doesn't work at all. Any questions before we continue? So 2 of your IXLs are checking to see does the solution work. 2 of your IXLs are checking that a solution works. So again, that homework assignment will go up later. So let's look at the first type of solving, which is graphing. So we just finished a section on graphing. So to solve a system by graphing, first step, rewrite each equation into slope-intercept form. So that means it has to be y equals something. It has to be in y equals format. So both of your equations here are already in y equals format. So we're good to go. Now we graph. Remember, if you don't understand something, you got to come off of mute and ask. When you're just sitting there watching TV or trying to play video games and not knowing what you're doing, video game can't pass you to class. First equation, y equals negative 4x plus 8. So your slope is negative 4 over 1. And your y-intercept is 8. Go to your y-axis, put your point on 8. Your slope is negative 4 over 1. So go down 1, 2, 3, 4 to the right 1. Go down 1, 2, 3, 4 to the right 1. 1, 2, 3, 4 to the right 1. And then draw your line. Hopefully your line will be a lot better than mine. Now we draw the other line. 2/3 x minus 6. Slope is 2/3. Y-intercept's negative 6. Same rule applies. Start in the middle, go down to -6. Go up 2 to the right 3. What happened to the 2 lines? They intersected. If your lines intersect, that means wherever they cross, that's your answer. So they cross at 1, 2, 3, 1, 2, 3, 4. 3, comma, -4. So that's your final answer. 3, comma, -4. Wherever they cross, that's your answer. If they cross. Any questions before we continue? You can always ask yourself, could I have solved that by myself? If the answer is yes, okay. If the answer is no, then that means you should ask the question and get the clarification that you need. Let's do another one. Y equals -3/2x plus 1, and 3x plus 2y equals 10. So we have our 2 equations. So the first equation is good to go. So our slope and our y-intercept. What's our slope? So for that equation, what's the slope? Somebody said it. -3/2. Remember, the slope is in front of x. If y is by itself, the slope is in front of x. The y-intercept is the number sitting off by itself. That's 1. So let's graph it. Go to the y-axis, put a point on 1. Your slope is -3/2. Go down 1, 2, 3, to the right 2. Keep going until you run out of space. Oops. Messed up with that one. 1, 2, 3. 1, 2, 3, 2. So the second equation, we got a problem. It's not y by itself. So here's my equation. I need y by itself. So what do I have to do first? I need to get y by itself. What do I have to do first? Subtract 3x. So I'm glad that Ashley and Camille are the only ones here. Aaliyah, Christian, Josh, Kiana, Khabib, Margaret, Sterling, Shay, Savannah, Miguel, Mariah, Tyler, and Will. I hope you're not sitting in the bed. Y'all computers work. Y'all signed into class, didn't you? Subtract 3x on both sides. So you have 2y equals negative 3x plus 10. Now what? So y is negative 3 over 2x plus 5. So now it's rewritten. So your slope is negative 3 over 2. Your y-intercept is 5. Any questions before we continue? So now we graph it, just like we did the other problem. Take the y-intercept, put it on the graph first. Your slope is negative 3 over 2. Go down 3, to the right 2. And go the other way as well. I'm going to draw that line too. What do you notice about those two lines? Parallel, they don't touch each other. So, parallel lines means you have no solution. Parallel lines mean you have no solution. Can't have a solution if they don't cross. Can't have a solution if they don't cross. Any questions? Example 2. We'll use one more example of graphing. Let's do one more example of graphing. Yeah, remember, closed mouths don't get fed. So, if your mouth is closed, that means you're letting me know that you know what you're doing. Which means I will find out later. Jonathan, good to see you. But I'm not just need to see you after class. We got a conversation we got to talk about some things here. So, I'll see you after class. All right, example 3. So example 3 is no different than example 2. We had one that was set up and one that isn't. One that was set up and one that wasn't. So let's knock out the one that was set up. Y equals negative 5x minus 2. What's the slope? 5/1. Beautiful. What's our y-intercept? -2. So go down to, on the y-axis is -2. Go down 1, 2, 3, 4, 5 to the right 1. I can't go down any further. Go up 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 to the left. Any questions before we keep going? All right, so that means you got the other equation. So this equation has to be y equals something. Y equals something. So what do I got to do first? Add 10x on both sides. (10x plus -2y equals 10x plus 4. Negative with it, divide by -2 on both sides. So y equals 10 divided by -2, -5x. 4 divided by -2, -2. What do you notice? That same equation. Same equations. So there's no sense in graphing it twice. It's the same thing. All you would be doing is tracing the same line. All you would be doing is tracing the same line. So that means if you have two of the same equation, or two of the same line, then your answer is equal to infinitely many solutions. So some of your teachers will let you put IMS for short. Don't type IMS in IXL. I don't think it will know what it means. I don't think it's going to know what it means. So that's my advice to you. Take it for what it's worth. Any questions with solving systems by graphing? All right, not seeing any, not hearing any, so that means we get to keep going. That's the first way to solve a system. That's by graphing. Second way to solve the system is by substitution. So substitution is just like when you play if you're an athlete, if you're a sub, you go in for the starter. It's the same way in math. If you work, you go on break, someone else is going in for you while you're on break. In math, when you solve the system by substitution, you're taking a number or an expression and plugging it into another equation. You're taking something that's already set up for you and you're solving it. You're taking something that's already set up for you and you're solving it. So we got 4 examples of substitution. Hopefully there will be enough time left over to do the word problem that goes with it, and that's where we'll stop for today. So the first example is the easy substitution. This is easy substitution. X equals 1, and x plus 2y equals 5. They're already telling you that x is equal to 1. Plug it in. So you take x equals 1 and you plug it in. So if you plug in x equals 1, 1 plus 2y equals 5. That's some easy stuff. Subtract 1. Divide by 2. So x is equal to 1, y is equal to 2, 1, comma 2. That's easy substitution. That's light work. So let's take it up another notch. Let's make it an expression. Make it an expression. So y equals 4x. Y equals 4x. So since y is equal to 4x, you're going to take 4x, plug it in for y. Take 4x, plug it in for y. So if you're asking yourself, well, how do I know that I set it up correctly? You should only see one letter of the alphabet in your problem if you plugged it in correctly. If you still have 2 letters of the alphabet in the problem, we got a problem. Something ain't right. So now we work it out. What's 2 times 4x? 8x. So you got 3x plus 8x equals negative 66. And then you divide by 11. So x equals negative 6. So now we know part of our answer. So if x is negative 6, how do I figure out what y is equal to? Get into the first equation. So y equals 4x becomes y equals 4 times negative 6, negative 24. Oh, this is so familiar because I just taught my brother this same stuff yesterday. I forget what junior college he's at, but I know he's doing the same stuff. Questions 1 or 2? Let's keep it going. So example 3, you got a little bit of a variation. This time, you have 2 equations that are y equals and y equals. You have 2 equations that are equal to the same variable. So that means you can take the problem and set them equal to each other. The problems that are equal to each other. Go ahead, man. At least that allows me to know that you are alive and kicking, and hopefully you're paying attention over there. So, if you have two equations equal to the same variable, then take the 2 parts that are equal to each other. Now we can solve this thing out. So if I want to solve for x, what do I have to do first? Well, we did that already. So since both of them are equal to y, we took the other 2 parts and set them equal to each other. So we got rid of the y. So to combine like terms, we either have to move the 3 over to the negative 5, or the negative 5 over to the 3x. Negative 5. We're going to have to add it to both sides. So those drop out. 3 plus 5 is 8. So 8x equals 16. So we got half of our answer taken care of. So we know that x is equal to 2. There you go. So you got 2 equations. You get to pick one. I'm going to pick the first one because it came first. 3 times 2 minus 7. 6 minus 7 is negative 1. Yeah, it's not hard. It's just work. It's not hard. It's just work. Any questions before we do the last example? I'll save the word problem examples for Thursday. All right, so the last example is what happens when you don't have a variable by itself. For the first example, you had already had a variable by itself. You already had something by itself. For the second example, you already had something by itself. For the third example, you add two equations with something by itself. This fourth example, though, we ain't got nothing by itself. So we have two equations with nothing by itself. We need to rewrite one of these equations. So which of these two equations would be the easiest to solve? Which one would be the easiest to get something by itself? First one. So we're going to rewrite the easiest equation. So that's y plus 6x equals 11. So which variable is it easier to get by itself, the x or the y? The y. Because all you have to do is subtract 6 over, x over. Minus 6x. Any questions before we continue? So let's make it work. So now we have y equals 11 minus 6x and 3x plus 2y equals negative 5. Take 11 minus 6x, plug it in for y. Now we can do a job. Distribute the 2. So it looks like I can combine some like terms. 3x minus 12x. Remember, this plus sign belongs to the 22. The plus sign belongs to the 22. So that's 3x minus 12x, negative 9x. Subtract 22 on both sides. Negative 9x equals negative 27. Divide by negative 9. X equals 3. Any questions before we finish this off? Let's finish it off. We know x. What do we do to get y? Three. Plug it back in. 11 minus 6 times 3. 11 minus 18, negative 7. So your answer is 3 common negative 7. Any questions on the last 2 examples? So it got a little harder.